Well, good morning, everyone. My name's John Dobberstein. I'm senior editor at No-Till Farmer. Thanks for joining us today for our webinar with Estes Performance Concaves entitled Maximizing Your Returns While Optimizing Your Combine. With that, let's welcome our feature speakers today. Todd Dale brings a lifetime of hands-on farming experience to his role at Estes Performance Concaves. He continues to farm on his family's operation while applying his technical expertise at Estes. Prior to joining the team, Todd spent 11 years working for a John Deere dealership in Northwest Ohio, where he built a strong foundation in equipment performance and customer support. Our farmer panelist today is Shawn, a no-tiller and strip-tiller based in Southwest Minnesota and customer of Estes. He manages a diverse crop portfolio that includes high-moisture crops requiring precision and attention to detail. Known for his high-level management and economic excellence, he brings a valuable insight to this presentation. So without further delay, I'm going to turn the show over to Todd.
Hey, good morning, everybody. My name's Todd Dale. I've been working with Estes Concave since 2020, the very tail end of 2020, beginning of 2021. I am going to share my screen with you here for the presentation today. So it's going to be a little bit about the product, a lot about the product, from a little bit from the sales side of things and a little bit from the support and setting and kind of how to optimize a machine with our concaves in it. And some of this stuff is transferable to where, if it works with ours, it may be something that's worth your time investigating and seeing if it's worth, a change or something that you can make. So here we have our newest concave system. It's the XPR3 system. We released this in February at the National Farm Machinery Show in Louisville of 2024. And as you can see here, we've got 2 or 3 examples. We've got the John Deere system in the upper left. Case flagship system is shown in the upper right, and then down at the bottom we show the fence system. There's a few others. We do have systems for the 88, 66 series, the Heritage or Legacy. I've heard them called all different types. But this is just kind of an overall. And then in the background here, we've got an actual screenshot from one of our customers in Iowa of a photo through the window of his corn as he was harvesting it. So we'll jump right into it. Any questions you may come up with, you can, I think, either ask them on the panel or we'll get to them at the end of the session here. Okay, so rotor combines. That's one other thing. Our concave system will only work with a machine with a rotor in it. We do not have an offering for walker or cylinder, the older cylinder machines. But basically with a rotor, the operation is the same regardless of what color, make of combine you've got. It is just a compression of crop where the rotor is squeezing, throwing the crop into the concave system, and the physics of how this does work doesn't change. It's the only thing that you've got that can really change and try to make things better, as we've done here with these XPR3s, is the concave system that's assisting the rotor in this process. So we got, here is just another kind of a highlight of the system. We're showing in the photo here the XPR3 Plus, which means our 3 concaves on a John Deere combine, and then 2 of our separation grates. So the concaves are where you're going to, that's going to provide you with the one system for all crop feature. So with these XPR3s, it does not matter to us whether it's corn in the Midwest, rice in the South, soybeans, wheat, canola, barley. We had a customer of ours out in the Northwest doing camelina grass seed, which is something that I've not really heard of, but he ran that last year with these new concaves. I was out there while that was going on. And then that same customer is actually going to run some carrot seed the next couple of days with a pickup head, and all of this will be done with this system that you see here. And again, he has a John Deere combine. If he had a case, it would work the same. But basically, the bars are the patented part of our project or our product. It's made from a round bar, round stock, and then we notch out, depending on how you look at it, say something like 120 degrees of the bar. So you get, and I've got a better slide coming up that'll show the bar comparisons. But the notch in the bar is the patented product, and then with the separation grate, we change the curvature of that. So we're allowing more space inside the rotor cage for material to stay in a more fluffy state. And that's a terribly unscientific word, I know, but if the material's fluffy, once it gets to the back half of the rotor, there's still a chance, if there's grain in there, that it can separate. What happens so oftentimes with the standard grate from Deere or a wire grate from Case is that the material wraps around the rotor, kind of forms a crop mat. And then as you can see here on these photos, the fingers that we have are sticking inward, kind of protruding into the rotor a little bit. And the intent there is to pierce through that crop mat, keep everything loose and fluffy, and give the grain a chance to still escape from it. So the other feature, as you can see at the top there, all crops, no cover plates. So in the past, we'd made cover plates for our system, and they would have to be utilized in some crops, some situations where with these XPR3s, there's no cover crop or no cover plates, which means you simply bolt them in, whatever combine you got, you bolt them in and you're done. You don't have to, the only adjustment you'll make to the concave from that point on is opening or closing it from the seat of the combine. So some of you may be familiar with samples like this. If you've got your own storage, this one here came out of the bottom of one of our bins on our farm. And you know, it's when you start with grain that's up in the high moistures of 25, 28, 30, 32%, it's very key to keep that kernel in a whole healthy state going into the bin. Now, this was taken with, not with our concaves, but you know, the process of a kernel of corn in a grain setup, going through all the augers in the combine, into the pit, up a leg, in the dryer, up another leg, in a bin, and then falling, you know, could be 100 feet to get to the floor of the grain bin. And it's really important to keep the bottom of the grain bin as healthy of a crop as you can, just because all of the air that you're going to be moving through that bin through the rest of the year, you know, if you have this image, it's going to struggle. You'll get hot spots, you'll get moldy corn, you'll get those pillar type structures that form as you're emptying the bin. And that's one thing that we really try to help improve, and we do a good job of improving, is keeping grain quality high when it's in the grain and when it's in the grain bins. And it just makes your dryer work better. I mean, a dryer is supposed to dry corn. It's not supposed to dry cob and stalk and chaff and that type of thing. So again, the tighter and faster method here, as this slide's kind of labeled, it only works for so long. And when you get to a high moisture or a damaged crop, you know, it could be a disease-ridden crop, trying to maintain quality is extremely important and can cost farmers in general a lot of money if it can't be maintained. Here's a little bit better picture of the bar. So again, patented design. This is the bread and butter of our system. And you can see that the notch in the bar is somewhat opened up. So basically you get the two notches for, ultimately what that is that's providing threshing surface area. Surface area is the key to all threshing. You need to have surface area available so the rotor can utilize that in its threshing process. So This is going to be 250% more threshing surface area than a typical round bar concave would be, where you've got basically like one aspect or one point of that round bar that's actually able to do the threshing. Where now you've got an entire 2 notches that are going to do it. So the grain quality is going to come from this. And one of the features of this bar is that the rotor speed will be slowed down. I mean, on a John Deere combine, a lot of the times 300 is kind of the max for our corn. That may be 100 RPMs or more less than what you're typically used to running. On a case combine, it's a little bit more rotor speed just because it's a different style of thresher, but 330, 350 on the corn is about as high as you'll get with our bar. And you'll end up with a better sample quality. And anytime you can lessen the rotor speed, sample is going to go up quality wise, and losses are going to come down because it's spending more time right here in this area, so that the threshing can be maximized to the highest potential. Better storability clearance, we've hit that. Okay, next one. So here's kind of the best image I can show you on these different, and there's different types of concaves out there. Obviously different companies, everybody's got what they like to, that works for them. So up in the upper left here is the XPR3 patented bar. 250% more threshing surface area, that's the key. Stops the loss, increases the quality, and gives you a great ROI. The upper right, that's the original bar of Estes Concaves. We started with that bar back in 2010 or 12. I can't remember what it was. A lot of people in the industry call that kind of a Pac-Man bar. It's a 90-degree notched bar. And we still sell our original RPR system today. It's one that we really only sell. We would really prefer it for those that are buying that to be in a corn and soybean area only, and those crops are dry. You're not fighting green stems. You're not fighting high moisture crop, because that square edge at the top there can be pretty damaging for grain quality, especially as you're kind of pushing things. If you're 15, 16, 18% corn all the time, that this 90-degree bar would work well, and it has for several years. But when you start to really push and get 20% or higher on corn, and the green stems on the soybeans, that bar can be a little bit tough on the crop and material flowing through the machine. Lower left is a round bar, pretty typical for John Deere customers as the OEM offering in corn and soybean country. At that point with the round bar, you're just squeezing. It's just squeezing. I mean, it's compressing until it pops one bar off, or kernels off the cob, so that it can continue to thresh the rest of the kernels off the cob. But again, some unthreshed grain is a problem, especially as recently with the soybeans being as tough as they are. Everybody, me included, is a round or two of fungicide and foliars, and then seed breeders are keeping life into the bean. So we have less and less of the sudden death and less of the white molds and things like that. So it's challenging. Like harvesting green stem soybeans is one of the more challenging tasks that a combine will go through. And a round bar kind of dates the combine, and it's just not going to do the job that these aftermarket options are. And it's definitely not going to do the job that the XPR3s will. And then in the lower right, there's a square bar. Not a lot of those out in the industry. Those are really, really good for threshing. I mean, they will get the corn off the cob, beans out of the pods, but it takes power to do so. And it can be tough with high moisture grain. And then the biggest thing probably is green fodder of any type is going to want to kind of hairpin and wrap up on those square bars, maybe limiting your capacity a little bit. So kind of in just showing off a little bit what our bar does in comparison to what else may be out there, what else you may be running. Getting into a little bit more performance wise here. So this slide, like I said, no covers, no bands, no reconfiguring for any crops. You simply just bolt these in, let them take place of your existing concave, and the one is going to do all. And then on the slide here, we've got some comparison. So this would have been, I remember I did this while I was at the dealership. We used dealership stuff to do this. We had a 690 combine and a 16-row corn head. We were in northern Indiana for this test. And basically what we did was we would do 3 swipes, 16 rows at a time. One was a round bar configuration. The next set of 16 rows was a round bar and a small wire combination on the John Deere combine. And then the third one was with ours. So tried to be, and we were changing concaves on the same machine. So we wanted to completely eliminate, the machine to machine differences that you may have. So this was all one machine, changing concaves throughout the day. And then had it, taking it into the elevator and using the numbers on the monitor for all of this information. So you can see here, barely, I wish I would have made the numbers a little bit larger, but the Estes XPR3 bushels per hour at 1%, or it was a little bit less than 1% of loss. 74.98, so nearly 7,500 bushel an hour. And now, to be fair, not all hybrids are capable of this, and I'm talking from a harvestability standpoint. There are hybrids that harvest really easy. I mean, just doesn't take much. The kernels kind of almost explode off the cob. You don't bring in a lot of trash. It's got to be the right hybrid. We were in 4 or 5 different fields until we finally got to a hybrid that was one of these high harvestability hybrids. So these numbers are, let me just stress, that's capable of doing that. It doesn't mean that every single hybrid, every single day, you're going to go and do 7,500 bushel an hour. But this was, by that, it was about 7.8 miles per hour, which I don't know if any of you have harvested corn that fast, but 16 rows at a time, it's nerve-wracking and it's uncomfortable. I mean, you can't see hardly anything. The corn stalks are just all chewed apart. It wasn't, the head wasn't doing a good job. So I completely understand that this is not a normal use case, but all I'm doing is showing you differences with our product compared to an OEM. So compared to the John Deere, it's 35.78 at 1% of loss. The FM was about 3% to 0.2%. And the way my screen is, I can't see the full right-handed picture there. The other 3 items that are listed on the looks like acres per hour, percent of splits or damaged corn, basically, and then savings, I think, on loss. So see if I can figure out how to move this. All right. So next thing is same test with the case combine. This was a 9250, 18 row, 20 inch corn. Same combine, going back and forth between the concaves. And here again, you can see the difference. Not quite the capacity of what we could get with the John Deere combine. And so these weren't the same fields. They were different hybrids. Might have been something there, but we weren't quite able to get up to the same top bushels per hour on the case combine as we were on the Deere. But nonetheless, still plenty, and still a good job with the foreign material, acres per hour, grain quality, all of that you can see here as well. So this was, again, 9250 combine, It was an 18 row, 20-inch corn head, and then we were just changing modules out. So I should also mention that this would have had our four, on the case combines, they have 4 concaves and 4 separation grates. So all of these, even with the round bars for the case, they were still done with our 4 separation grates. Just like on the deer, we had 3 of our concaves, 3 of our separation grates. For both, for the round bars, the factory configurations, as well as ours. Okay, get into the setup a little bit, and I'll go pretty quick through this because this is more for existing customers. And if you're an existing customer and have questions, by all means, please, now is the time to ask. But most of the time, the problems we see, the concaves are installed but not leveled. And the chaffers and sieves are not calibrated. Zeroing the concaves, basically that just means recalibrating the concave, whether it's a deer case, it doesn't matter. But whatever your new zero is after it's been leveled, you want to go through the process and make it so your display is actually showing that as 0. Improper configuration, this could be a mountain of things, from deep tooth chaffers when it should be general purpose when it should be deep tooth, rotor bar configuration, that type of thing. And then operating problems we see the most is on the right here. So bringing in too much trash, watching the monitors rather than looking at the ground, making a bunch of changes at once and still running them like an OEM or like your operator's manual of that combine would tell you to run them. We have a different set of settings, and the way you run them is, ours are different. It takes a different type of operating and adjustments to make them work. So here's what we send with every set of John Deere concaves. This is the installation sheet. It's also on our website, where we walk you through the process of how to make sure the concaves are set to 0, re-leveling them, setting them. The one thing that we do different is for our number 1 concave compared to our number 3. The number 1 is, when we level it, we actually use a physical measurement of a 1/4 inch and then 1/8 inch in the rear. So basically, as the material is moving through the combine, it's got a little bit of a pinch, an 1/8 of an inch. But in the concave world, millimeters matter significantly. So if you start with a little bit bigger hole in the front, and then as you move it, as the material moves back, with our concave bars, that works really well, because it's going to kind of pinch the material, and you start with the most material up front. As you move to the back, you're getting less cobs, or less corn on the cob, less beans still in the pods. So by applying that pinch to the concaves really helps with getting the material all threshed and separated the proper way and as efficiently as possible. Next is on the flagship combines. So I don't know how, and this is one thing that kind of caught me off guard with, where we started putting in there to shift the rotor cage. So the case combines have the ability to shift the front half of the rotor cage right or left in comparison with the rotor. So ultimately, you're able to change your pinch point. And a lot of the times on a flagship combine, and this applies to all types of concaves, it's going to overload a little bit heavy on the right side of the combine. The shaker pan right up front will have a bigger pile on the right side than it does on the left. Shifting your rotor cage will help alleviate that problem regardless of what concaves you have in there. Because as it says in the operator's manual, you want to shift your cage towards the pile. And basically you give more room on the right side and you make your pinch point on the left side, so that as the material's coming in, it's got more room over here, but it's going to your pinch point, trying to thresh and throw material off to the left side to try to eliminate or alleviate that overload. And that's more common in higher yielding, higher moisture crops than it is in, if everything is perfect and it's 15 bushel corn or 15% corn and or 12% wheat. But if you get to where you're pushing it a little bit on the moisture, shifting that rotor cage is significant, will give you a significant advantage compared to what you come from, regardless of the concave type. So that may be something you can take home with you. Again, this is just the setup sheet that comes with them. So now the tough spots, the tough things, and kind of where our system is going to set itself apart. Green soybeans, green stems, rotted stems, leaf spot mildew, all of these things are problems that we all see and we all face every year. So with one thing that we really try to give you as a benefit, I guess, is when you get to these, and the one way our system works, when you get to these situations and you kind of live in these situations, it can be really aggravating as a combine operator. You always wish you could go a little faster. You always wish the loss was a little less or the sample was a little cleaner. With our concaves, you can still do that. So the versatility of them is pretty remarkable. So in green stems, rubbery pods, but the beans are dry, you can set a concave to clearance of 3 or 4 and a rotor speed of 700 or 800 with our concaves. That'll still give you a really good quality soybean without the splits, without the damage, and it's going to chew through all the green stuff. Same thing within the corn. The corn, you want to keep your quality, and with ours, it's a little bit different than what you're used to, where you always wanted to open a concave up so that it doesn't damage the kernels. Well, a lot of the times with ours, you might end up running a concave clearance and high moisture corn of 20 millimeters or 22 millimeters and a rotor speed right around 300 or 280. And again, the difference is the notch in the bar. Letting that notch do the work time after time, revolution after revolution, is going to get the corn off the cob. And then the large gaps that we've got between our bars is going to get the grain out. So as soon as it's threshed, it's out of the rotor cage, down in the cleaning system. It's not staying in there and tumbling around, getting beat up every trip around it makes. Wheat, the same thing. Quite a few, for about the last 10 days, getting quite a few calls on wheat per settings. It seems like the big part of wheat country this year was maybe a little bit behind with all the rain they had. So that made initial starting a little bit tough, maybe pushing it a little bit because they were behind, and it was a lot of 18 and 20% wheat. And so after, talking with different growers from over that way, one thing that works really about every John Deere combine this year, a concave clearance of 8 and a rotor speed of 830 has been working just phenomenal for everybody. On the flagships, it's been similar. It's been like a concave clearance of 10 and a rotor speed of about 950 to 980. So be interesting to see and hear comparison wise what you're used to compared to what ours are working at really well this year. Another thing that you're going to get out of ours on the wheat side of things, wheat, oats, anything that you're keeping the straw is straw quality. Because of that slower rotor speed, you're going to get a little bit better quality of straw sent back out the combine and be left to bale up for you. High moisture corn. So kind of what I just hit on there, concave at 20, rotor at 330. Fan pretty well maxed out. And then it's got, have a couple different, very specific things for the setup. The pre-chaffer extension removed. You got to know which chaffer and sieve you have, regardless of what concave you run. All belts are tight. That's one that kind of learned a little bit at the dealership, but there's especially your jack shaft belts on the right side where it runs the fan, and your shaking action of the chaffer and sieve. A few of those, if you turn it, you should be able to turn it about half, but not much more than half. Rolling the belts, just grabbing it in your hand and rolling. If you can do more than that, it's probably time to look at either finding a tightener or an idler to tighten it up, or replacing the belt, because You start to lose revolutions on your shaking, on your chaffer and sieve moving. You start to lose separation and cleaning capacity. So that's one thing you got to check before every season, and most probably get an inspection done, and that would be done by your dealership. And then the other thing is keeping the machine loaded. That's a secret. That's not a secret. That's been ever since a rotor combine has been around. Rule number one has been keep it full. It's got to be full to be effective. And that's no different with our concaves. But a lot of this information that we've got on this one, and then the next couple slides of soybeans and wheat, is all available on our website. We've got a website that we send out to all of our customers that buy the concaves. Gives you the crop settings, the tips and tricks, so to speak, depending on the condition that you're in, that type of a thing. So again, same thing. Kind of talked about the green pods and stems. Here we've got an example starting a concave at 5, rotor at 750, chaffer and sieve 12 and 4, and a fan pretty fast. And that's one thing with our system you'll also notice is that your fan speed is going to be higher than you're used to. And the big reason is a lot of the design of the concaves, the design of the grates, that's intended to really keep the material in the rotor cage rather than letting a bunch of chaff and fines get out of the rotor cage. So if you have less trash on your chaffer and sieve decks, you can run more fan speed because the fan speed's not really going to blow out too many single grains. I mean, the smaller grains, I get it, but corn and soybeans, it's pretty hard to blow clean grain out the back of a combine. Now, the more trash you have, the more it can ride out the back of the combine on the trash. But for just setting the combine and getting it once it is set and you'll find that the fan speed is going to be one of them that's also going to be a little bit higher than what you're used to running in the past. Wheat, kind of the same thing. We've had a lot of guys go to stripper heads over the last couple of years, it seems like. And so last year I spent about a week out in southeast Colorado, right on the Colorado-Kansas line in big wheat country, very incredibly variable yielding wheat. But a lot of the one farmer that we visited he had stripper heads, draper heads, our XPR2s, XPR3s. He had a little bit of everything. So it was a great place to go run. And I got to learn a lot about stripper heads. And it's the stripper heads with our system can be something that's just maybe the most impressive of all, because it's always been, well, with a stripper head, you can't really keep the combine full. So a little bit of the design integrity of these XPR3s were actually geared towards stripper head use, just because that seems to be an up and coming trend, if not already, in the wheat harvest world. Okay, so here's a number that's get a little sales pitchy on you. ROI. Everybody wants to know ROI on everything, as you should. And so I've got here 237% ROI on the first year. And this may be a little bit conservative, but for the average up here, and again, I can't see all of the numbers, but I think I got it from memory. So this example is 1,000 acres of soybeans, and if they make 60 bushel an acre. So with our system in the combine, these are numbers that came from our farm, John Deere Operations Center, just data that the combine gives you. We've got, at my dad's, he's got a 770. So compared to the regular round bar concaves, we were 0.3 gallon an acre less fuel, 1 bushel an acre less loss, 1.5% less DOC, and that would have been on non-GMO beans. A lot of the times at the elevators anymore, everybody sees the same DOC. They just probe you, move you on, dump you, get everybody out of there. But with these crops that actually have a premium to them, you'll see them graded a little differently. And that was the case here. So ended up being $26 an acre of a positive in your wallet, and that applied to the 1,000 acres ends up being about 237% in just 1 year on just one crop. So those numbers are pretty applicable across the board, regardless. Excuse me, regardless of the crops you grow, and it's not uncommon to see even larger numbers, quite frankly. So cost of the system, we have different configurations that you can have, but it's basically anywhere from 7,000 to 15,000. And so depending on your combine, your situation, this is the kind of numbers you're looking at. So that's my that's the presentation that I've got. Please ask questions. I'm going to turn it over to Shawn. Shawn's been a customer of ours for longer than I've been here, maybe 2017 or 18, Shawn, I think. Very diverse grower, very progressive grower. One of the guys that we, like me especially, I lean on him a lot. He's always one of the first in the crop, whatever crop it is. I've seen some pictures of the corn that Shawn's picking, and it's as green as this little strip of ROI here. So he's a really good one to get. I'm glad he could join us today, and I'll turn it over to him.
Yeah, thanks, Todd. So yeah, we're growers, farmers in southwestern Minnesota by Laverne. So we're just across the border from Sioux Falls, South Dakota. We grow corn, soybeans, triticale, hybrid rye, cereal rye. We've done some milo. This coming fall, we're going to be harvesting some sunflowers. So we've been putting these concaves to the test when it comes to switching crops, changing crops. We've been running. I think we've run, like Todd mentioned, several versions of their concaves. I've got the most time on the XPR2s as far as just acres through them. And then along with that, we also have a 4,000 head feed yard. So we do take a lot of high moisture corn, and high moisture to the point of pain in the ass. My brother does all the feedlot stuff, and he likes it the wetter the better. So typically each day starts with us fighting about what number of corn or what moisture is too wet and not too wet. But so we'll take anything that we can pretty much get through the combine. So we'll start combining somewhere around 34-35% moisture. And these concaves have allowed us to do that. We used to do just regular round bars. And obviously, since we're a feed yard, we're putting them through a roller mill. So as far as grain quality in that sense, maybe that's not as big of a concern for us in that environment. But still, the biggest trouble is just the problem. If you're grinding up that corn, then it turns to mush, and you've got a combine full of goo. And so we obviously don't want to be beating up the kernels just because it plugs up the sieves and the chaffers and all that stuff. So, yeah, I guess that's kind of what we do and what we've seen. We've seen a lot of the same stuff that Todd has talked about as far as reducing loss. That's really probably the biggest reason we went to these concaves was just tired of seeing losses out the back of the combine. And then, we've been running S780s for quite some time. Went through some 670s, some 680s with them, and then now are going to be running the S7 800s. But yeah, just kind of, I guess that's an overall thing. I don't know, Todd, if you want anything else me to highlight or anything like that, I guess, or if guys just have questions or.
No, I mean, I appreciate you being here. If we've got any questions, I'd be happy to take the rest of the time that we've got to answer them. You or I, whoever it applies more to.
Todd, did I see that you do no-till and strip-till?
Shawn.
I'm sorry, Shawn.
Yeah.
Yes. Yeah. We're primarily a strip-till, no-till situation. Our beans are, we probably do about a third to half of our soybeans as no-till. We do a lot of no-till with our small grains. Our corn is all strip-tilled, just because of our being as far north as we are, cold, wet soil. So, yeah, that's kind of our practice.
Right. Did you notice that the concaves helped with managing residue in your fields at all? I don't know if that was an issue or not, but
Managing residue is obviously always an issue. And I feel like all I do is chase our tail when it comes to managing residue. You think you got one thing figured out, and then the next year you got some sort of different winter and something that's completely different. As far, probably the thing I notice, or that we notice with residue management, is maybe not directly related to actual residue management, other than most of the time we feel the Estes takes less horsepower, which allows us to basically, when you're trying to run all that residue, especially combining beans in a no-till / strip-till situation, you're picking up old corn stalks, you're picking up all that old crap that sometimes goes through them. I feel like it allows us to have a little more horsepower to manage all that extra crap that sometimes comes through the combine, if that makes sense. But as far as actual difference in the residue itself, I can't say that I notice much difference.
right. Todd, you're talking about with the concaves that you make that you can reduce rotor speed a little bit. How much on average would you say that operators can do that?
It's gonna vary a little bit for the crop and the situation, I guess. It's not uncommon. I guess a response when I'm selling the product or helping someone set up the machine while they're in the field, I'll say, well, where's your rotor speed? And if they say 450 in corn, I'll say, oh my goodness, that's way too fast for our stuff. I mean, you need to be like 280 to 330. So in some cases it may be half, depending on what that farmer's used to doing, but more oftentimes than not, it's probably going to be 100 RPMs probably in each case, and that's if the condition allows. And then the alternative of that is if it needs more rotor speed because you're not getting things threshed, you should be able to do that with our concaves too, and still be able to maintain a pretty good quality of seed. So it's going to reduce the rotor speed, yes, on average. By what number, it's going to be a little bit more location or farmer specific, maybe.
Right. Just note for everyone in attendance here, feel free to ask questions. These guys are here to answer them. As far as high yielding corn goes, as you know, people are pushing more yield, more crop. Any changes in design you've had to make over the years to work with high yielding corn more, or have you pretty much addressed that off the outset, do you think?
No, that's a good question, I guess. So the best response for that would be, we've started with the RPR system in 2010 or 2012. That was number one. Went to the original XPRs in maybe 2014. From 14, just a couple years with the XPRs, and then to the XPR2s, which we had for about 5. The XPR3s are new in 24. So we're of the mindset at Estes that the crop conditions change all the time. I mean, as farmers, and it's all us as farmers, it's all our fault because we want more and more and more and more, and companies and seed providers, fertilizer, everybody can give us more. But that makes the harvest condition a lot tougher. So these XPR3s were brand new for the 24 season. And I'd done some testing and development on them from 22, 23, and then we released them in 24. So I think as far as, adaptation to change, it's going to be, it was really hard to make a concave that was better than the XPR2s. And it's going to be really hard to come up with a design that's better than the XPR3s. But if that's what's needed, we're going to do it because we're going to keep adapting and trying to simplify the farmers' jobs as much as we can as far as a harvesting aspect goes.
Right. Jake Gross has a question here. What is a realistic capacity improvement to expect? He wondered if 200% was maybe a little bit too good to be true. Maybe you can provide some insight on
I
that.
think the two. Oh yeah, that's that. Like I said, that was a pretty perfect situation with that test in comparison. This may be one better for Shawn to answer if he
Yeah. So I guess what I'll do is I'll also, we run two machines. The last 2 years, we've been running one machine with XPRs and one with a condex set, actually. And what we're seeing, so I've given up on round bars, just to be perfectly clear. The old style regular factory round bar, in my opinion, for what I'm doing, is scrap iron. So what we've done is gone to the condex just because Deere was trying to work with us because we were telling them, they needed that their system wasn't working and we were using Estes. So we've been playing with them. So to make a short story long or whatever, we basically are picking up about, in corn, on average, we're picking up about 700 to 800 bushels an hour, pretty respectively, pretty across the board. If I average it out over several thousand acres, that's about where it lands, with a little less fuel usage per hour as well. So that, I guess that's what I'll say. I mean, I don't want to. Everybody's conditions are different, so it's really difficult to say, yep, it's this much percent. This is what you're going to get. Because like Todd said, the thing with the Estes Concave is, number one, that thing has to be full, and sometimes it gets uncomfortable how fast you have to drive to make that happen. And so that's sometimes as operators, I mean, usually I'm running one of the machines, but not always. We got other operators that run them as well. And so you got to be pretty comfortable in a machine to be running those 6-7 mile an hour with, 40 or 45 foot drapers or whatever that may be, to keep them full. So, you have to take that with a grain of salt of what kind of operator are you and how you want to handle that. And if that's what feels comfortable to you, to make it happen. But I think I would stand behind, and maybe Todd could chime in if he thinks that's not a normal number to see on corn, but I would say pretty easily 500 to 800 bushels an hour on corn. We can run, again, variety makes, it's still amazing to me how much difference variety makes. It is unbelievable what one variety versus another can make. But I mean, we've run varieties, 260, 280 bushel corn. We were pushing 780s, somewhere in that 5,900 bushels an hour. Had John Deere engineers sitting with me that day, and they couldn't believe we could get that kind of bushels per hour consistently with the kind of grain quality and the little bit of loss. I can get a John Deere concave to get to that point. I just can't keep most of it in the combine. So I guess that's what we see.
Right. Anything you want to add to that, Todd? Or
no, that's a pretty common number that we'll hear a lot of the time is maybe a semi-load an hour or something. Somebody will say, and so that's fairly, and it's just, again, so variety specific. Some of those times it really can almost double your capacity, and then other times you're going to be lucky to get 300 bushel an hour more. That's the truth of it. So
right, great. Good deal. Tell me just a little bit, Todd, about your company, where you're located, and when you were founded, and just so our attendees know.
Yeah. So Estes Concaves has been around since like 2002. Started in the concave world with the disruptor kit for the separation grates, which was just a way to, the guy's name was Don Estes. He designed these basically finger things that you just bolt into a separation grate, and it helps minimize the rotor loss. Just gives a little bit more stirring action And so since then, we've taken that design and created our own separation grate to take place of that. But Estes is based out of Frisco, Texas, and then our production facilities. We've got our own factory facilities that we make all of our stuff in house now. So that's all in northeast, small farm town in northeast Texas. So everything ships and corporate offices are in Texas. I myself, I live in Indiana. I work remote, kind of do most of the traveling and for field setups or troubleshooting type things. So I'll be all over the place. And then we're companies based out of originated in Indiana when it was Don Estes's deal, and then we moved to Texas when the grandkids took over.
Great. Well, thank you, Todd. Well, I think we're out of time. We have answered all the questions that were sent to us. Want to thank everyone for attending today. As a reminder, today's presentation will be made available on the No-Till Farmer website, and you'll receive an email within the next 48 hours of the recorded presentation. So you can watch your email for that, and you can go back and refer to it again. On behalf of Estes Performance Concaves, Todd Dale, Shawn and No-Till Farmer, thank you for joining us for today's presentation, and enjoy the rest of your day.